Good morning, friends. In this lecture, we will discuss about the equation that we will use for the gearbox numerical, and also we discuss the different parameters used for gearbox. So we already know a few parameters, that phi, it is geometric progression ratio, Rn is the range ratio, Z spindle speed step, and we will see more parameters in this video. So we all know that Z is equal to number of spindle speed step, and Rn is equal to range ratio, and for Rn we know the equation Rn is equal to phi raised to Z minus 1 that we derived in our previous lecture, taking log of this equation in both sides. So we can put log 10 Rn is equal to log 10 phi raised to Z minus 1, and by solving this equation we get Z minus 1 is equal to log 10 Rn upon log phi. So we are putting minus 1 from left hand side to right hand side, we get this equation, and cross multiply in this equation we get this final equation, Z is equal to log 10 Rn into phi upon log 10 phi. So this is the equation for Z, it is log 10 Rn phi upon log 10 phi. Now next parameter is N. Capital N is number of stages for gearbox. So if we want to change any gear, if we have two stage for that, so it is 2, so the value of N is 2, and if we have 3 different stages for changing of gear, so for that N value of N is 3. Now for that we need to use few formulas. So Z, all we know that Z is equal to number of speed step is equal to number of speed step in first stage and number of speed step in second stage, and so on, number of speed step in last stage. And we know the number of stages is N. So Z is equal to P1, we are putting P1 in place. P1 is equal to number of speed step in first stage, and N2 is equal to number of speed step in second stage, and so on, number of speed step in nth stage is Pn. So we can use Z is equal to Pn into P2 into P3 up to Pn. And to obtain the required speed step, it is necessary that all states should have same number of speed step. So we can say P1 is equal to P2 is equal to P3 is equal to Pn. So we can use P instead of all these terms. So Z is equal to P into P up to n term. So this we can use Z is equal to P raised to n. So applying log in both direction, left hand side and right hand side, we can use log 10 Z is equal to log 10 P raised to n. So from that we can derive equation of number of stages of gearbox, n is equal to log 10 z upon log 10 p. Now the value of p that we use p1 and p2, it may be 2 or 3. If we are putting the value of p and we are getting the value of n in non-integer, for that we have to use this equation as z is equal to 2 raised to n1 into 3 raised to n2, where n1 is number of stages with 2 speed steps and n2 is equal to number of stages of 3 speed steps. And here we are putting the value of z and we get one equation, and we will find the value of n1 and n2 which satisfy this equation. In this way we get the value of n as n is equal to n1 plus n2. So we have to use first equation. It is n is equal to log 10 z upon p. If we get non-integer value for this equation, so we have to use this equation to find the n. Now we know the arrangement of gearbox. So for that we will use structure diagram or kinematic diagram to show which gear is used and how they are arranged. And to find that we will use structure diagram, and to draw a structure diagram we will use structure formula. So we already derived one equation. It is z p1 into p2 into p3 up to pn. So from that we can generate the structure formula equation. It is p1 x1, p2 x2 and p3 x3 upon pn xn. Here the x1 x2 x up to xn are number of spindles speed step by which two adjacent speed values of particular stage are separated. For the first stage it is px1, and for the second stage we can use x2 and so on. And to find the value of x1 x2 we have to use this series. We have to put x1 is equal to 1, x2 is equal to p1, x3 is equal to p1 into p2, x4 is equal to p1 into p2 into p3, and in general formula we can use xn is equal to p1 p2 p3 up to pn minus 1. So from this tree we can find the value of x1 up to xn. So this we can put in this structure formula. Thank you.